What would you say if the past would only be one click away? If you could take a virtual walk through great cities like Lausanne, Venice, or Amsterdam on your journey through history. A group of researchers at the EPFL Lausanne, as part of the European Time Machine project, aim to create an open data source rebuilding the history of European cities. Using artificial intelligence and machine learning approaches, the researchers are able to digitize and process different types of historical records, such as books, maps, paintings, and photographs, in order to build a comprehensive historical 4D simulation of the past.
If you have to invest a lot of time to get a single information, then you will be more likely to focus on a small data set, to reduce, and then to finish with some qualitative study that brings some very interesting element, and that is often a very in-depth understanding of a specific event, a specific person, a specific place. But what Time Machine brings is the possibility to have the big picture.
One of the main goals of this local time machine, and more in general about the time machine project, is in fact to allow researchers, allows people that are simply interested in these kind of topics to go through these documents in a more simple and more fast way than they did before.
We see that there's a lot of potential trying to bring the past to the present, and not only to the specialists, but in a very large idea of democratization of this knowledge.
The Lausanne Time Machine focuses on different aspects of history, including iconography, population, architecture, as well as city and territory. So let's take a closer look on how the scientists at EPFL digitize and process historical maps in order to rebuild Lausanne of the past.
Used to reconstruct digitally the city, follow several steps. The starting point is the georeferencing, is the process of georeferencing that happens once we have collected all the cartographic documents, and it consists in assigning the correct geographic coordinates to replace, in fact, these images to our physical environment, to our physical space. After this step, there will be the vectorization. That means converting a raster image, because in fact the archives gives us these cartographic documents that are always in a raster format into a vectoral one. Also, this process can be done manually, but also automatically.
So all the technologies we develop, or most of the technologies we develop, are based on neural networks that are artificial networks that have the capacity to learn progressively from a set of training data. So the first step in when working with any kind of data is usually a step of annotation. In this phase, you have to simply take your data and to think, what do I want to semantize, what do I want to make understandable in my data. So you will take Photoshop, let's say, and you will progressively annotate and give some examples for your neural network, your super AI, to learn on them. You're like a teacher that tries to explain what is a cadastre, what is a house to your computer. In the third phase, this is the best phase, is the phase where you try to infer. So your computer will try to learn directly from your data and to interpolate, if you like, to extrapolate his knowledge on other data, on other maps that he has never seen. So you have this image that depicts things that are easy for us humans that are trained and knowledgeable to recognize, but that originally are impossible for a computer to differentiate from single pixels with no logic. And the computer, through all this training process, will be able to set classes to differentiate different elements of the map, such as buildings, roads, non-built, or water. And here they are. You obtained all your parcels that are individually segmented. And when you group all this, you get your super Google automatic Google of the past.
Using advanced digital technologies and computing infrastructure, this project creates huge digital archives documenting the urbanization of Lausanne and giving important insights on landscapes, agricultural organization, and the evolution of buildings throughout different time points in history.
Cadastre is always composed by cartographic part, but also has a land register where we can find important information about inhabitants, about the nature of parcels and their property, for example. It's really interesting to cross, in fact, the spatial information with the social and economic ones. And this can allow us to make some interesting visualization, to really understand in a new way also new relations and new dynamics of social and urban configuration of the city of that time, for example.
City or a region, you have to benefit from the effects of this digital transition. And then from an historical point of view, it's important to point that the history is not a small object made up just for a few significant cities or parts of territories, but everything is equally important and interconnected, and which is why a global approach must always be taken.
The Time Machine initiative enables to navigate through time by adding another dimension to the searching tools we know today. By mapping the economical, geographical, social, and cultural evolution over time, these projects turn big data sets into a living social and economic resource and provide an important tool to learn from the past in order to improve our future.